Hello, so today we're going to be covering series, and this is our first session on series out of our two sessions we're going to have. So, what is a series? A series is a summed up sequence of numbers guided by a specific mathematical arrangement. It's a summed up sequence. Now, I think from all of us from our earlier learning, we've known what a sequence is. For example, if I have 1, 2, 3, 4, dash, dash, you can guess that the next number here is going to be 5 and this is going to be 6. Why? Because you can tell that we are adding 1, we are adding 1, we are adding 1 from each. Now when you get this sequence and you add it up, the sequence becomes a series. So that's why we are saying that a series is just, you get a sequence. A sequence is separated by commas, and a series, we are going to see a series like you have pluses between. Though however you can have maybe, let's say, pluses which are silent. Let's say if I have something like this, here they are silent pluses because this is negative, but yeah. So we're going to see as we go on. Now, so here as we can see here, you see that it's obvious. It's plus plus. So this will be 6. This will be 7. Then from this, when you try to subtract 12 minus, you don't see any common difference. So here, how it's going, I think when you say 12 out, 12 divided by 3, you get 4. So here it should be times 4. Then this is also times 4. So meaning that our next term in that equation is going to be 48 times 4. And I think 48 times 4, what is 48 times 4? Okay. So 48 times 4 is 192, like that. So also 192 times 4, you get 768. Then that one times 4, you also get 3072. So now this is a series. These are sequences, sorry. Now, when the above sequences are summed up, they become series. So that's what we're trying to say here. So they become series. Now, I'm going to set for us a few fundamental rules. Every time you're faced with a series, there are certain things you're supposed to note. Now, this should now stick to your head in your mathematical. A is going to always represent the first term, and D is always going to represent a common difference, and R is going to represent a common ratio. Now, what I would want to say is that you don't just get any random sequence until maybe 3, 18, 21, 33, and then you call it a series. Or, and yes, and then you call it a series or a sequence. Usually, a sequence like has a pattern, and now that pattern can either be it has a common difference or it has a common ratio. Otherwise, it would be senseless to just have random numbers, because then it would be hard to determine what's coming next. But for these things to be called series, is that there is a pattern. There is either a common difference or there's a common ratio. That's why it's important for you to know that D represents a common difference. It's important for you to know that R represents a common ratio. And now for every series you have, usually, except if they are specified, you should check whether does it have a common difference or does it have a common ratio. And usually you can do that in your head or in your calculator. Let's say now for this one, you have this, you can try say 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. So now why is it called a common difference? Because it's common to all the consecutive terms. Here I'm saying 2 minus 1, 3 minus 2. You get it's the term minus the term before it. You don't reverse it. So that this term minus the term before it, like that, they should all have a common difference. Now that's why here I come and write the first term here is 1. Then the common difference D is also 1, meaning here I can predict by just adding a 1, the answer would be a 6. Now here when I come and say that was the first term 3, make it let it stick to you that always when you have this number, first try to interpret what you've been given. So now for this case, I just even automatically I pick out that my first term is 3. Now I come here and try, does it have a common difference? I'm asking myself, does it have a, but with time you don't even have to, you just look at it and you can tell. So for example here I try 12 minus 3. I think this is 9. Then I also try 48 minus 12. I try 48 minus 12. This is 36. So you realize these numbers also have a difference, but the difference is not a common difference. So these numbers have no common difference. Then I try, how about a common ratio? We don't just call it a difference or a ratio, we say common difference, meaning it's supposed to be similar in like consecutive terms. So I come and try and say 12 divided by 3, what do I get? 12 divided by 3, my answer is 4. You see? Then I try 48 divided by 12, 48 divided by 12, 48 divided by 12, what's the answer? The answer is 4. So I come to a conclusion, these two have a common ratio. So here the common ratio is 4, but I think you can look at it and tell. You don't have to like write all this down. You just look at it and say, maybe show the exam that you're looking for. Your common ratio, say R is going to be 12 out of 3, which is 4. So you have your common ratio. Okay, so now here we know that there's a common ratio. They are multiplying by 4 the consecutive terms. That's how I come and see it's 48 times 3 is going to be equals times 48 times 4. It's going to be 192. That's the next term. So now we've gotten that is like the basics. Now we are going to see their types of series. There are two types of series. We have APs or arithmetic progressions and GPs or geometric progressions. Now, what are arithmetic progressions? Remember, I told you for any series, it should either have a common ratio R or a common difference D. That's why we don't just get any random numbers and then we give them to you. No, these numbers should be having a pattern. Now, for arithmetic progressions, what we're going to start with, there are series which have a common difference. So meaning even if I give you unknown terms and I told you that it's an AP, just know that APs have a common difference between any two consecutive terms. For example, here you see that our first term is 2. I told you make it a point to always, this is number 2, sorry, this is number. So our first term here is 5, our first term here is 2. Now for this case, when you come and get the difference, you see 4 minus 2, you get 2. If you also try 6 minus 4, that's why it's called a common difference, that even if you try any consecutive terms, it's giving you the same. Even here, when you come and try what's the common difference, this is 17 minus 11, this is, what is 11 minus 5. Here we have 6. Here we have 6. Then here 23 minus 17. We also have 6. So here there's a common, even here we have proved there's a common difference. Meaning what can we can tell that you adding 2, 2, 2, 2. So here it will be 12. Here we can tell you've been adding 6, 6, 6. Here we can tell that it's going to be 23 plus 6. So the consecutive term is going to be 29. So now we are going to go more into APs. Just get it stuck into your head. APs have a common difference because in the future they're not going to be always giving you very many terms. Now, from our understanding, we're going to build a concept file. So here, see, if we have 1, okay, we have this. Okay, let me start. If we have 1, 2, 3, 4, 5, these are 5 consecutive terms. I want you to look at these are 5 consecutive terms. Now, when you look at these terms, they have a common difference they have a common difference of 1, because you see 2 minus 1. Okay, let's do it here side up. We have 1 plus 2 plus 3 plus 4 plus dash. So our first term A is 1. What's our common difference? Our common difference is going to be 2 minus 1, which is 1, or D is equal to 3 minus 2, it's still 1. That's the common difference. Now, how are we getting each of these terms? We are adding 1. We are adding the common difference. We're adding the common difference to get the next term. So just let it stick into your head that when you get the common difference, it's like that's the term you have to add to any term to get the next term. Because here you're adding 1, so here we're adding 1, we get 5. Now, let's say we didn't have these terms, and our first term is A. So if our first term is A, what is our second term going to be? It's going to be A plus the common difference. I've told you to get the next term, you get the term before it plus the common difference. Like here, you have 1. To get the next term, you get 1 plus the common difference, 1, you get 2. So here we add the common difference. So then to get the third term, we are going to say the second term plus the common difference, you see. Then to get the fourth term, we get the third term, which is what we are just picking this from here, plus the common difference. To get the fifth term, I'm going to get the whole of this, A plus D plus D plus D. Then I add the common difference. That's the concept I'm trying to show us here. Now, if we try to come up with a conclusion, the first term is A. The second term is A plus D. The third term is a plus 2d. The fourth term is a plus 3d. And the fifth term is a plus 4d. Now I want us to make a quick comparison while looking at the coefficients. The coefficient is something that's accompanying a number. If I have something like 3a, the coefficient of a is 3. That's the meaning of the word coefficient. If I have 2, if 2a, and I ask what's the coefficient of a, the coefficient of a is 2. You get? Now when I try to observe these things, the a is constant for first, second, third, fourth, fifth. The a is constant. And also now when I look at the common difference is increasing, its coefficient is changing. Now look at, for the first term, there is no d. For the second term, the coefficient of d is 1. For the third term, the coefficient of d is 2. For the fourth term, the coefficient of d is 3. For the fifth term, the coefficient of d is 4. Now, what does that mean? When you compare, realize that for every term, let's say the fifth term, the coefficient of d is less by 1 of that term. Let's say here there is 5, here there is 4, here there is 4, here there is 3. It's like the coefficient of d is always less by 1 of that, like that number of term. Meaning, if I wanted to get any random term, maybe like the nth term, it will be a plus n minus 1 d. So if I was trying to and maybe find the fifth term from what I'm telling you here, fifth term is going to be a plus n is 5 minus 1 d, which is equal to a plus 4d. That's what I'm trying to tell you, that when you look at closely at those coefficients, the coefficient is less by 1 of that, let's say of that nth term. Now from this, we are going to get a formula. Now, whether you've understood how we've come up with it or not, the most important thing is understanding the formula and what it means. Now, this is the formula, where un is the nth term of an AP. It's going to be a plus n minus 1 d. This is the formula. Now, this formula, it's in our log, in the logbooks. I think some people use L to represent the term, but for me, I'm going to be using UN. Now, I'm going to give us an example to show what UN is. Now, if I have 1, let me use a series: 1, 2, 3, 4 plus dash plus dash. This is the first term. This is the second term. This is the third term. This is the fourth. This is the fifth. This is the sixth. What is A? I told you always first try to interpret what you've been given. A is 1. What is D? The common difference is 1. Because how am I getting that? 2 minus 1 is 1. Or you can also get it by saying 3 minus 2. Because this is a series, I told you they all have their, it's called a common difference. You do common to everything. So the common difference I have is 1. Now, if I want to find the fifth term, and I want to use this formula, UN is representing the fifth term. So if I want to find the fifth term, I'll come and say my formula is UN is equal to A plus N minus 1 D. So here I have U5, the fifth term. U5, the fifth term is going to be equals to A plus 5 minus 1 D. This N is representing the position, the nth term, the fifth term. That's what it means. So here, if I want to find the U5, it's going to be equals to this. Then you substitute. You can choose substitute from the start, but I'm trying to avoid the collision. So this is 4 times 1, which is the fifth term. The fifth term is 1 plus 4, which is equal to 5. Similarly, here someone would have just come and said plus 1, which is 5. Here you can say plus 1, sorry, which should be 6. Now that concept, even if I want to find the sixth term, I can use this formula still. Now for this case, this number is obvious. You don't even have to use this formula, but I'm trying to show us how application of the formula. If I want to find the sixth term, that's what I'm trying to say, the expression for the nth term. That if you want to find the nth term of any AP and use this formula is going to give you the answer. So now the formula UN, where if I want to find the sixth term, that means n is 6. So U6 is equal to A plus 6 minus 1. So here the D I know it is 1. So U6 is going to be 1 plus 5 times 1. U6 is going to be 1 plus 5. U6 is going to be 6. So this is our answer. U6 is 6. Okay. So now what I'm trying to show is the formula, how it works. Now, everyone, before you can pause this video and first write this formula at the back of your book or on a random paper about 10 times, or the more you write it, it's going to keep getting stuck in your head and it's going to make the calculations easy. Though, however, this formula is in the logbook. Yeah, but it's better if it's at your fingertips. It's not a hard formula to understand. Now we're going to look at our first example. we're going to slowly by slowly apply the principles we are learning. Now, given that an arithmetic progression is given below, what does an AP mean? It has a common difference. So here we are lucky that they even gave us more terms. We can prove that it's an AP, but however, someone could even have just given you just these two terms, because the fact that I've told it's an AP, it has a common difference. But now for this specific number, you have 6 plus 11 plus 16 plus 21. Someone could try to prove it and say A is 6, and then they say, so what is the common difference? This is 11 minus 6. I think this is, this is 5, right? Then now if I also try and say 16 minus 11 is still 5. But if I also try and say 21 minus 16, so you see, they have a common difference. But they already told us it's an AP. So what I'm trying to say, someone can still give you a number and say 6 plus 11 plus dash, and I've told you that this is an AP. So you don't have to ask. The fact that it's an AP, it means there's a common difference. So you work it out in the same. You just have to subtract once. 11 minus 6 is 5. You have the common difference. Okay, now here we are having this question. So since usually we have this, you try to rewrite what you've been given, then you obtain they want us to find the common difference. So part one. But however, let's first try to find out what we have. We have the first term is 6. Then the common difference we've already seen how to get it up there. This is 11 minus 6 is 5. Is equal to 16 minus 11. This is a common, it should be common. Actually, if you ever find a number and you try to say and it's not a common difference, just know that number probably has a, if it like they've said it's an AP, but when you try to check the common difference, it's not the same, that number has a problem. Or if they say it's a GP, when you check for the common ratio, it's not the same, that means that number has a problem. Like this series, there has to be a pattern. We're not just working them out randomly. Now here they want us to find the 21st term. Now here we have to find our formula for the 21st term. Our formula finding the nth term is un is equal to a plus n minus 1 d. Now for this specific question, they want us to find the 21st term. So meaning 21st term n is 21. So we have u21 is going to be equal to what is a 6 plus n minus 1 d. This is 5. This is 6 plus 20 times 5. So this is going to be equal to 20 times 5 is 100 plus 6 is 106. Meaning, it says 106. U21 is equal to 21 is 106. So 21st term is 106. Okay. Then now we go to our next question. It's saying the sum of the first 4 terms. Now for this question, for now it's simple because you already have the 4 terms. So you can say 6 plus 11 plus 16 plus 21, and you put it in your calculator. 21 plus 16 plus 11 plus 6, and your answer is 54. Yeah, that one we would have gotten it. Then now if you got this question, the sum of the first 100 terms of the progression. So now for this one, someone would think maybe we are also going to go and keep looking, but now by the time you reach the 100th time, you're going to get tired. That's why now we are going to introduce another formula that can help us find the sum without us having to list all the terms. Yeah, you don't have to list all the terms to find the sum. Now that's why we're going to this formula, the sum of the first n terms of an arithmetic progression. Now for this one, there's a way to prove it, but it's not important. You can just get it in your head like this. Just have to get it in your head. This is sum of the first n terms of an arithmetic progression. Yes, and so even similarly, you should pause this video and write this formula on a paper or the back of your book so many times. Why? This helps it to stick in your head. If it sticks in your head, it's going to make it easier for you to remember it. Now, some of the first in terms of an arithmetic progression, I always want us to start with uh, a simple simulation so that this thing makes sense. Now, I told you when you have any arithmetic progression, always try to identify what have you been given. So here I have my first term, a is 1. What's the common difference? 2 minus 1 is 1. Or I told you for it to be called a common difference, you should be sure that there's a, when you subtract any term minus the term before it, what I mean is you get 2 minus 1, not 1 minus 2 minus 1, and then 3 minus 2 like that, 4 minus 3 like that. That the term, the consecutive term minus the term before it. Then now we have D, so we have D is 1, we have A is this. Then now we want to find the sum of the first, let's say the first 4 terms. Now here it's simple. Let me say sum of first 4. Simple, you can say This is 1 plus 2 plus 3 plus 4. So this is 5, this is 10. This answer here is 10. But still, we can now use our formula. Sn is equal to n out of 2 into 2a plus n minus 1d. So we're going to find the sum of the first four. That's where n is 4. So here 4 out of 2 into 2a, where a is 1 plus 4 minus 1 times the d, which is 1. So here 4 divided by 2 is 2. So I have 2 plus 3. 4 minus 1 is 3 times 1. So I have 2 times this is 3 plus, so this is 5. So you see, I have the sum of the first 4 terms is 10. So what should we note as when we are going to be using this formula? This formula is sum of the first n terms. First, like when we're starting from the first term, that's how it works. It always works for the first n terms. It's not just a random formula. Okay, then now we're going to look at a few examples. Then we're going to look at a few examples. Then we can close the chapter.